Hello, in this video we're going to be looking at precession, what it is and how we can answer some questions involving it. Let's look at this gyroscope spinning. If you look at the top of the gyroscope, you can see that it isn't staying in one place. It's moving around and tracing out a circular shaped pathway. This is similar to the Earth as it spins. And this means that the location of the North Celestial Pole will change over time. Whilst currently the North Celestial Pole is located near to Polaris, it will eventually move towards different stars. Here you can see the complete rotation of the North Celestial Pole, and it will take approximately 26,000 years to complete a full rotation. So, over the next 6,500 years, the North Celestial Point will move away from Polaris and towards Alderaan and then further. And then you can see over the remaining thousands of years, it will move closer to Vega, and then eventually round to Thuban, before completing the cycle with Polaris regaining the status as the pole star and the process beginning again around about 26,000 years in the future. So what impact does this have for us on Earth? Well, it can be useful for archaeologists to use this astronomical knowledge to try and date ancient buildings and monuments. Often they were aligned to certain celestial bodies on key dates. As the process of precession causes the North Celestial Pole to change, the buildings will misalign from the stars they were originally built to align with. Here you can see the building was built to align with Polaris, but now no longer does by 28 degrees. And we can use this information to date the age of the building. If we know that in 100 years the rate of precession is around about 1.4 degrees, and we know that the building is misaligned by 28 degrees, then we can work out its age. To get from 1.4 to 28, we must multiply by 20. And therefore we need to do the same to the other side. And multiplying 100 years by 20 gives us 2,000 years, an approximate age for the building. Let's have a look at another example. Here, an ancient monument was constructed so that on the date of the winter solstice, it would be aligned with a certain star. The alignment of the stars is now 33.6 degrees from the star. The average rate of precession is 1.4 degrees per century, and we need to calculate the approximate age of the monument. So again, we know that in 100 years, the precession rate is around 1.4 degrees. So to get to 33.6 degrees, we need to multiply by 24. We do the same to the other side, and multiplying 100 by 24 gives us 2,400 years as the approximate age of when the monument was built. Now that we've had a look at precession, see if you can have a go at some of the key questions.